Okay. All right. So let's first real quick. Polynomial. All right. Poly just means many. All right. So it just means many terms. All right. Many terms. Now, in the past, recently, we've been just talking about monomials. Monomial just means a single term. Now, let me explain what separates terms. Terms are separated by addition and subtraction. Are terms separated by multiplication? No. All right. Only addition and subtraction separates terms. So if I say X, that is called a monomial. If I say X plus Y, that's called a what? Binomial. Thank you. Very good. X plus Y plus Z is called a what? Trinomial. All right. What is X, Y plus Z called? A binomial. That's very good. Listen all the time, and that's what would happen. All right. So again, terms are separated by addition and subtraction. All right. Now, what I want to tell you, if I had something like X squared plus Y squared plus Z squared minus 2X plus 3Y, we just don't list it. We just say that's a polynomial. That is many terms. All right. So you're going to hear a lot of times somebody say monomial, binomial, and trinomial. That's what we talk. All right. And anything past 3 terms, we just call it a polynomial. All right. Anything past 3. I mean, there is terms for things past 3, but in math, we just don't talk that way. All right. It's a monomial, binomial, trinomial, or it's a polynomial. All right. Now, the next thing is, in order to be classified as a polynomial, X has to be to a whole number. In other words, it could be to the 0 power, to the first power, to the second power, to the third power. All right. It cannot be X to like 1.5. That is not a polynomial. It cannot be to the -1, or it cannot be 1 over X squared. The exponents must be whole numbers. All right. The exponents must be whole numbers. And again, you're never going to have a variable in the denominator. All right, because a variable in the denominator would make it negative. Okay, so with that being said, I now need to talk to you about degrees. All right, so the degree, if I had just a constant, and a constant is just a number, for example, 3. All right, technically you can write this as 3x to the 0 power. So if you have a constant, the degree is 0. Now, believe it or not, I don't think I've ever given on a test what's the degree. All right, this is just information. All right, this is just information for you. All right, now, because of that, all right, just give me a second. All right, if I said 5x, what's the degree of that? Well, x is to the first power, right? So the degree would be what? 1. All right, if I said, for example, 7x squared, what would the degree be? 2. Now, all right, if I said 7x squared y, the degree is going to be what? 3. Thank you very much. That was smart. 3. All right, the reason why we say it's 3 is because y is to the first power. All right, it's not a big deal. Welcome to the class. Still pay attention, Jackson. You're on a roll here. All right. Hold up a second. No, don't just grab. All right, the degree is 3. Why is the degree 3? Because the degree is the sum of the exponents. All right, now one more thing I'm going to show up here. If I said for you, for example, 7x squared y squared, what's that degree? 4. This is a monomial. Now, if I said plus, let's say x to the 5th, what is this degree here? What's the degree? What's the degree of x to the 5th? 5. All right. Notice this is a monomial, and this is a monomial. And together it makes a what? Binomial. So you look at the individual degree of the monomials. So what's this degree here? What's this degree? So what do you think the degree of the binomial would be? The largest one, 5. All right, it would be 5. Is everybody with me on that? All right, just basic rules. And like I said, it's not going to be on a test, but sometimes on the SAT or something, they might tell you that. So one more time, you're going to look at the individual monomials. This degree here is what? What's that degree? 4. What is this degree? So the overall degree would be what? 5. All right, and I'm going to write one more example, and then we're just going to go to the worksheet and get it done. All right. So let's say I have x squared y minus 3x squared y squared plus 5x cubed. What is this called? Monomial, binomial, or trinomial, or polynomial? Trinomial, because there are what? 3 terms. Terms are separated by addition and subtraction. What's the degree of the first term? 3. What's the degree of the second term? What's the degree of the third term? Therefore, the degree is 4. It's really simple. Really simple. I don't even put it on the test, I don't think. All right. Anybody have any questions with that? Yes.
If you added a random number like 5, is that considered a term as well? Plus 5.
Now it'd be a polynomial. There are 4 terms.
So it's a term.
That's what I just said. It's a term. All right. Terms are separated by addition and subtraction. Is this a polynomial now? No, it's not a polynomial anymore. All right. So you would say, no, it's not a polynomial. All right. Now, again, please stay with me. All right. Let's do this. Let's get it done. All right. It's really, really simple. All right. So if I look here, it says determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it's a monomial, binomial, trinomial. So let's just put this to rest. Number 1 is a what? Monomial. All right, it's a monomial. And what's the degree? 0. All right, constants have a degree of 0 because it's the exponent of the variable that you're looking at. Bless you. All right, number 2, yes or no?
No.
No, thank you very much. Confidently. You can't have a variable in the denominator, so it's no. All right, now number 3, they're trying to trick you because 7x minus 1x is what?
6x.
Yeah, so just rewrite that for me as 6x plus 5. So now this is considered a what? Binomial, and its degree is what? Degree is 2. Really simple, really simple. So number 4, what is this called? Come on, trinomial. And as soon as you don't know something, you just tell me. I'm not sure why it's a trinomial, but that's called a trinomial, and the degree is what? Somebody who's paying attention, tell me.
4.
Wow.
2.
Wow. 3. The degree is 3. Now, individual monomials. So highlight. The first term has a degree of what? 3, because this is to the first power. The second term has a degree of what? 2. And the third term has a degree of, therefore the degree is 3. There you have it.
Can you go back to number 3 real quick? I'm confused how the degree isn't 1.
It is 1. Thank you. It is 1. I don't know why I said 2. Wow. Love being corrected. What? It's a constant. There's nothing to be confused about. The degree of a constant is what? What are you acting like? That's a mystery. It's a fact I'm telling you. You have to write in your notes somewhere, the degree of a constant is 0. That's it. I don't know why they decided to choose it to be 0. I have no idea. All right, that's a rule. That's a fact. All right. So now number 5, is that a polynomial? No, it's not a polynomial. All right, for question number 6, this is a what? Binomial, and the degree is what? That's right, degree equals 2. All right, that's good. Now, write each polynomial in standard form. All right, this is important. And I'm never going to really ask you what the leading coefficient is, but the leading coefficient is simply the first number in front of the largest term with the highest exponent. All right.
Number 6, obviously, could be 1.
What's the degree of this? What's the degree of the second term?
2. No, I mean, why is it binomial? Like, I only see 1, like, addition sign.
How many terms are there?
2.
So why do they call it a binomial?
There's 2 terms. Okay.
Trinomial is 3 terms. All right. You're not counting the addition and subtraction signs. All right. So here we go. Standard form, largest exponent to smallest. And I've already taught you that last year in pre-algebra when we did things. All right. You always write things in descending order. All right. Largest exponent to smallest exponent. So number 7, how do I write that? X to the 5th plus x cubed minus x squared. That is standard form. That's how simple it is. All right. Mathematicians want to stay consistent. So to stay consistent, you say largest exponent to smallest exponent. And Evan, the constant is always written last. All right. Now remember, a constant is just a number that doesn't have a variable. That's it. All right. So that's another rule. The constant is at the end. All right. Now, the leading coefficient, what's the number in front here? The number is a 1. All right. So again, these are just terms. When you get to higher level, they'll talk about standard form. They'll say, what's the leading coefficient? They'll ask you about the degree. All right. These are just terms. All right. That help you communicate. That's it. All right. No real math here. All right. Now, number 8, let's write it in standard form. So to write it in standard form, what comes first? Negative 7x to the 5th. Thank you. What comes second? Plus x to the 4th. What comes third? Plus 4x cubed. And then what? Plus 1. What? Okay, now let me help you a lot. You ready to look up on the board? All right. Last year, I tried to teach you that when I was first teaching about positives and negatives to help you, I always told you the sign in front determines whether it's positive or negative, right? If I know that x to the 5th is the largest exponent, you agree with that, right? How many x to the 5ths are there? -7. You with me? Now, look at the x to the 4th. Is x to the 4th positive or negative? That's why I put a plus sign right there. Look at the x cubed. What is it? +4. And then the constant is always last, +1. That's all there is to it. Largest exponent to smallest exponent, we call that descending order, and you throw the constant at the end. All right, the constant's always last. What? Trey, what? What? It better be good.
So the numbers in front of the exponents don't matter. It just matters on
I have no idea what you just asked me.
Well, why would a -7 be first?
Well, what do you want it to be? What do you want to be first? Let's go with that.
Wouldn't the
Shh.
negative number be the smallest number?
By exponent.
So
The largest exponent to the smallest exponent. Which one has the largest exponent? There you go. Right, descending order according to the exponent. All right, and the leading coefficient is what? -7. All right, I'm never going to ask you that. All right, but that's what that means, leading. It's not that hard. Coefficient just means the number in front of the variable. Just like the coefficient on the x cubed term. What's the coefficient on the x cubed term? 4. Thank you for listening. All right, let's go to 9. Here we go. Write it in descending order. Reese, go.
2x to the 8 minus 3x to the 6 minus x to the 8.
That is excellent. Easy. That's all there is to it. Nothing to it at all. All right, here we go. Number 10, Trey, tell me.
Negative 8 or negative x to the 8 plus 2x to the 7.
Beautiful. Exactly. All right, Misha, 11.
5x to the 4th minus x to the x squared plus 3x.
And don't forget, minus 2. That's it, guys. It's the easiest thing we've ever done. All right, super easy. All right, let's see how easy, Jackson. Go.
Negative 4x fifth minus
Yep.
2x to the 4th
Right?
plus x plus 3.
Yeah, come on. Don't be lazy. Just do the problems. It's really simple. Nothing to it. Now, last year, literally, we did this in pre-algebra. All right. This is when we first started doing the algebra stuff last year. All right. So it's just combining terms. All right. Now, in math, generally, you write in alphabetical order. So generally, you put the A's and then the B's, then the C's or whatever. All right. So if there's 2 things or 3 letters, it's always generally in alphabetical order. All right. Now, I'm pretty confident everyone in here can just do the mental math here. All right. If I'm asking you to add this right here, all right. Luca, what's the answer?
7a plus 1.
7a plus 1. Super easy. Like I said, I'm sorry, it's too easy. All right. Now, Evan, help me out with 14. What are you thinking? Only add if they're the same. Right? So does anything go with 4x squared? You see what I'm saying, right? The only thing you can add to x squareds are x squareds. Bless you. Do you agree with that? So tell me, what's the answer? Come on.
6x.
I want the descending order. What goes first?
4x squared
Good.
plus 6x.
Yes. You're asking me what 9 minus 7 is.
No, I know that is efficiency, right?
But like what?
Oh, I know. I'm confused by the addition, the thing in the middle.
No, don't be confused. You're just adding them. All right, Josh, 15.
It's gonna be 10.
10 what?
10xy
Good.
plus
Good.
plus 6
Plus what?
plus 5x.
Plus 5x. Everybody good with that? Now, if you put plus 5x plus 2y, do I really care? Do I really care? No, I really don't care. All right. Generally, you put them alphabetical order though. So I prefer 10xy plus 5x plus 2y. All right. That's what I kind of prefer. Tell me.
So you only can't add things together when the, like, so for reference number 14, you can't add this 6x plus 4x.
Squared, right, right. They're different. They're completely different. An x is completely different than x squared. The number in front, remember, listen to what I'm saying. The number in front tells you how many of those things you have. So right here, I have 4 x squareds. That has nothing to do with 6x. I have 6 what? X's. X is completely different. It's like a Y and an X. You can't add them together. They must be exactly the same in order to add them. All right, so what?
What if they were both
What does that mean? They were both one. 1x plus 1x squared. One apple plus one orange. All right, you can't add them. They are exactly different. All right, you can't add them unless they're exactly the same. All right, Allie, you're up. 16.
Would you add the exponents?
Multiply. When you multiply, what do you do to exponents?
You add them.
Right. So if I said what's 1x plus 1x, what is that? 1x plus 1x, 2x. If I said what's x times x, you would say x. That's right. That's what we took a quiz on yesterday. All right. So when you multiply, you add exponents. When you add, you're just combining terms. You with me? So now let me ask you a question. How many x squareds is the first one? What is that? How many is that? What number's in front? 1. What is this? Nope. What number's in front? Nope. What number's in front? Right. Negative what? Yes. Now you with me, right? So you have 1x squared minus x squared. What do they do to each other? Yes. You with me?
Yeah.
So there's no x squareds now. So now final answer, please. Shh. That's it. 2y squared. All right. Now the mistake is made by doing y to the 4th or 2y to the 4th. When you add, you're not adding exponents and things must be exactly the same. All right. So now number 17, Avery, let's go. Come on, say it loud and proud. For what? What power is that? Yes, 4p squared.
4p squared, and then
Right? And then plus how much? Seven and what? Shh. What is that, Avery? I don't know what you're not seeing. Do you see the number 3? I'm asking you a question. Do you see the number 3?
Yeah.
And do you see the number 7?
Yeah.
So what?
Oh, I didn't see that.
And you'd have to say plus 10. You'd have to say plus 10. All right, Brennan, go. Wait a minute. Wait a minute. 4xy squared. I don't even see a 4xy squared anywhere. Shh. Where is a 4xy squared? I don't see it. Combine terms. All right. Look at the first one. I'm highlighting 2x squared. Where's another x squared term? What kind of 6x squared? So what is that? Right. Okay. Now let's look at the next term, 5xy. Are there any other xy's? How many? Right. So all together. Why are you wanting to say y squared? What is it? 4xy. Okay, now what?
6y.
Do you add exponents?
No, but yeah.
2x squared minus 6x squared was negative 4x squared. Did you add the exponents?
No.
No. So what is 4y squared plus 2y squared?
Correct.
6y squared. That is correct. What? Shh, I'm hearing louder.
Why doesn't the 6y squared go before the 4xy?
Well, I honestly, that's why I'm saying I don't really even care. You with me? If you put the 6y squared, I don't care. But generally you go in descending order alphabetically. So what does that mean? This is a 2, this is a 1. So I look at the alphabetical order of the variables. X comes before y. So I would start with the largest exponent for the x and go to the smallest. Right? But again, I don't care. I really don't. I mean, when you get later, higher up in math, you'll learn to write better. For me right now, I just care, can you combine terms? Right? Combine terms, right? What?
Why aren't you adding the exponents?
Because when you multiply, what do you do to your exponents? Now, listen to me. Again, here's what's something I'm trying to tell kids all the time, because I literally figured it out. All right. I didn't memorize well. So I'm trying to show you. If I said to you, what's x plus x? What is that? You said that confidently. Of course, it's 2x. So did I add the exponents? This is a 1. This is a 1. You didn't say it's 2x squared. You said 1x plus 1x. What I'm trying to make sure I can help you with is this. The number in front tells you how many of the x's you have. If I'm adding x and I'm adding x, I don't change what I'm adding. In other words, if I add x's, I'm going to get what? X's. If I add x squareds, I'm going to get what? Exactly. If I add pencils, I'm not going to get something different than a pencil. Right? If I multiply, that changes things. When you multiply, if I said, what's x times x, you would tell me x times x, of course, is x to the second power. So now you just discovered the rule. When I multiply, what do I do to exponents? You add them, because you know x times x is x squared. All right, that's how you remember it.
So like if it was like 3x.
Oh, we got a lot more to go. We got a lot more to go. All right, so just stay with me. All right, now we're into something different. We are subtracting. So if you remember last year, what did I tell you to do with the subtraction sign? Make it what? That's correct. Distribute a what? Negative. That's right. Now, to distribute a negative, now we're just going to say, make the minus sign a what? Positive. Then the negative becomes a, and then the positive becomes a, and the negative becomes a. That's what you're supposed to be doing. You're distributing a -1. So when you distribute a negative, what happens to all the signs? They just do what? They just switch, or they change, or they become opposite, however you want to feel about it. All right, now it's back to easy. You're just combining terms. And as we go down the page, this is supposed to be foggy, and now it's supposed to be clearing up. The more problems you do, the better you're going to get. And believe it or not, the more problems that you do on your own, the better you become. Not just writing down my answer. All right, I've got about 4.5 more months to try to teach you that. You got to put the work in. So let's do that. All right, so number 19, Luca, you're up.
So it would be -18.
Let's put the squares first.
This way.
So how many squares are there? In other words, descending order.
Oh, there's 4.
I don't know what you're saying. I don't know what you're saying. Are we on 19? I ask you how many squares. Where are the squares up there? Shh.
Oh, 5. How are you my squares?
Do you understand? This is a square. That's something to the second
Oh,
power.
square, yeah, sure. All right, there's 1 square.
how many of them are there? The number in front tells you how many that, right. So you're going to write 6p squared. All right. Now I would go for my p's. How many p's do you see?
Well, there's one out there, but didn't it have to be square root?
Look, I'm just combining terms, buddy. I'm just combining terms. There was nothing I could do with the p squared. So that's done. Now continue combining terms.
So then plus 6r.
Look, do you see this 8p right here?
Yeah.
We're working on the p's right now. Is there anything else I can put with the 8p?
No.
No, so I'm going to write plus 8p.
Wouldn't it be negative?
Why would it be negative?
You said you switched all the sides.
Okay, Luca, did you watch? What signs did I change, Luca? This became a plus, this became a plus, this became a minus, and this became a plus. Now, what you should have said is you should have said, why didn't you change the 8p and the -5 to -8p and +5? But you just did that on your own. It's not something I did. You did that on your own. Is that what I did?
No.
No. So if you don't understand why I didn't make that -8 and +5, you should say, hey, I know you sound a little grumpy today, but I still want to ask you my question. Did I change the 8p and the -5r?
No.
No, because there wasn't a negative out in front. I said you're distributing the negative here. Now you're combining terms. All right. We did the 6p squared. And then we did the 8p. Now I'm interested in the r's.
Oh, 1r.
So how much is this, Luca?
-5r.
And what's this?
6r.
Nope.
Oh. Oh. So -1r.
Good. And then what?
Plus 3.
That's all there is to it. Now, do number 20 without my help. All right. And Eddie, what do I do with the negative?
So you do 8x squared, and then you add it with,
You didn't distribute the negative yet.
oh my god.
Come on, what do I do with that negative?
So the negative turns into a positive,
And the -2x becomes,
a positive,
and the -x squared becomes,
a positive,
and the 5 becomes,
a negative,
good. Now start with the square terms. How many square terms do I have now?
2,
So altogether I have,
10x squared,
why 10?
because you add 8x squared. Positive x squared.
And how much is that?
Oh, it's 9.
Yes, 8 plus 1 today is 9, I'm thinking. All right, I could be wrong, but I think it's 9. All right, now combine the x's. What do I get?
-4x plus 2x is -2x.
Now we're in business.
And then -3 plus -5 is -8.
Now we're there. Okay, Logan, 21. What do I need to do? Oh, hold up. Luca, how is that? Now, say it again.
I'm still doing yeah.
Okay, now, Luca, do 21 quickly. And I'm trying to help some of you guys. Don't sit and write down my answers. Do the problem. All right, I promise you it's super easy. All right, Logan, what do I need to do?
Do you distribute them?
And what do I get? The negative becomes a,
Positive,
and then the 3x squared becomes, and then the 5x becomes,
negative,
and the -1 becomes.
positive.
Okay, so now what?
The 2, 3x, those cancel out.
Just say the x squares term do what?
Cancel.
Cancel out. So now what?
You have -7x.
And
plus
then-
1
Yes, negative 7x plus 1. Negative 7x plus 1. Is everybody okay with that? What?
How do you want to do, negative?
If there's a subtraction sign. I know last year was kind of blurry for you. All right. So that's a negative 1. Do you remember that? Distributing the negative. That's what I'm doing. Distributing the negative. All right, Miss Pancholi, go.
Okay, so distributing.
Wow, using my words too. Good. So now what?
Okay, so then
Shh.
like it becomes like
What does the subtraction become?
positive,
And then the negative x squared,
that was positive,
and then,
negative,
and then,
positive.
okay, now what's next?
Distribute.
Okay, tell me what the next step is.
Okay, so would it be 2x squared?
Why 2?
Because I'm not like.
What is
oh,
this?
Oh, 1.
What is that? How many?
Oh, 5,
I highlighted the yellow, and how much is that?
4,
And how much is this?
1,
So altogether,
5.
wow, there we
I
go.
just said that.
Shh, shh, shh. All right, what's next?
Okay, then 8
Why 8?
plus 6 plus 2.
You told me to make this negative.
Oh, that's my bad.
I know, it's not
I
mine.
like can't see. Okay, 4,
What kind of 4?
positive,
4 what?
xy,
Okay, keep going.
and then 7y squared.
Okay, I'm gonna go ahead and say plus 7y squared. Okay,
Plus 7y squared.
all right, 23, that was good. Uh-oh, we got a problem.
No, there's not a problem. I still have a question. So you do alphabetical order for the.
Yeah, generally, but again, it's not all that big of a deal. All right, Misha, go. What do I do? Is that us? All right, guys, you got to finish everything. All right, I'll be collecting it tomorrow, and I want everybody to try those last 2 word problems too. All right, get it done. If you're having trouble, come see me in the morning. Boy, that was slow. The whole thing, all the way to 50. You're welcome.